Assalamu alaikum student, welcome to daily physics lecture. Today's lecture is 7. Today we will discuss about the most important and a pretty new topic of current electricity, and that's Kirchhoff's law. There are two laws which is given by Kirchhoff. It's not Kirchhoff, okay? It's Kirchhoff. So these two laws are known as Kirchhoff's law for electricity. Now we'll discuss about those laws. Let's start today's lecture. So first law, Kirchhoff's first law is also known as Kirchhoff's current law or KCL, and there is another name which is junction law. So there are three names: Kirchhoff's first law, Kirchhoff's current law, and Kirchhoff's junction law or only junction law. Okay, so the question can ask you in any way. So obviously, as the junction word is here, what do we understand about junction? Junction are the meeting points between different lines. We are familiar about a railway junction where more than one line meets, not CSD junction. Okay, so as we are discussing about electricity, so obviously we will deal with the junction of the current carrying wires. We'll discuss about the junction of the current carrying wires. Here, this is a junction, this point is a junction, and this junction contains 5 lines. 1, 2, 3, 4, 5. So at first our task is to denote this current. Okay, suppose this is I1, I2, I3, I4 and I5. We have to first denote it. Then Kirchhoff said that the summation of current flow in an electric junction is 0. So in an electric junction, the summation of current flow, that means summation of I is equals to 0. This is the statement. If the question asks you state Kirchhoff's law, first law, then you have to write this statement, not the other statement, this one. So summation of I is equals to 0. That's the mathematical expression of Kirchhoff's first law. And now we have 5 current. So if we want to sum all these 5s, we have to sum it. Okay. So there are currents in different directions. 2 directions, either inward or outward. So as there are 2 directions, so obviously we have to assume one as positive and other as negative. Let's assume, it's all about our assumption. The inward direction is positive, we assumed it, and the outward direction is negative, we assumed it. Then I1 inward, I3 inward, I5 inward. These are positive. So here we have 3 currents inward direction: I1 inward, I3 inward, I5 inward. So these will be assumed as positive. I1 inward positive, I3 inward positive, I5 inward positive. These 3 are positive current, and I2 and I4, look, these 2 are outward, so negative currents. So I'll write minus I2, minus I4. These 2 are negative, and we have to take the summation, that means we will have to put the addition signs. Sum all them. These 3 are positive, these 2 are negative. So if you take the summation, then summation equals to 0. All 5 current, if we sum them, then the result will be 0. That's Kirchhoff's first law. So from this line, what can we write? Let's take those 2 minus to other direction of the equal sign. So I3, I1, I3 and I5 are the inward current, I2 and I4 are the outward current. So we can write that summation of I inward, that is the inward current, is equals to summation of I outward. So we can also state Kirchhoff's law in other way, that in an electric junction the inward current is equals to outward current. Though this is the mathematical expression, but we will solve our problems by using this equation. Okay? So what types of question will appear from Kirchhoff's law? State Kirchhoff's law, or explain state Kirchhoff's first law, or explain Kirchhoff's first law. If this statement appears in question, then only you have to write this line up to this, not the figure or this explanation. But if question appears as 2 marks, explain Kirchhoff's first law, then you have to state first, draw the circuit, mini circuit figure, and then you have to write till this part. So you have to write for 1 marks only statement up to this, and for 2 marks statement, figure, and all this up to this. I hope you understand this part. Let's move into the Kirchhoff's second law. Kirchhoff's second law. It has 3 names. The question can appear as state or explain Kirchhoff's second law. Another name, Kirchhoff's voltage law or KVL. And the third name, loop law. Okay, so question may appear by using any name. Okay, so as the junction law was discussing about a junction, electric junction, so loop law will discuss about electric loop or loop inside of circuit. So here I have given you a loop which contains 1, 2 resistance, 1 and 2 cell, 2 cell. So please try to rewind previous lecture. I already gave you the idea about what is the task of a cell and what is the task of a resistance. What we do know, cell provides potential, which we know as the EMF, and resistance consumes potential, which we know as voltage difference or used voltage. The voltage used by R1 is V1 and the voltage used by R2 is V2. Then this circuit, then E1 and E2, these two are providing voltage to the circuit. V1 and V2, these two are the consumed potential from the circuit. And as we know, E is the supplied voltage by cell and V is the used voltage by resistance. So here E1 and E2 are the supplied voltage, V1 and V2 are the used voltage. So if we go for conservation of voltage, obviously in our world everything remains conserved. So why not voltage? So if we go for the conservation, then we can say that supplied voltage equals to used voltage, conservation. Supplied, used. So what is the supplied voltage? EMFs. So summation of E, total supplied. Summation of V, total used. How many supplied do we have? 2, right? And how many voltage do we have? 2. So we know that the voltage can be written as IR. So in place of V, that means the consumed voltage, we can write I into R. So this last line, this is the statement of Kirchhoff's second law. So if we write it down, then what will be the statement? Let's see. At the left side, the summation of the EMFs in a electric loop by cells is equal to the summation of the product of the current flow and resistance of that loop. Okay, so that's the statement. Let me tell it again. The summation of the EMF of the cells of an electric loop is equal to the summation of the product of current and corresponding resistance of that loop. This is the statement of Kirchhoff's second law. So two types of question appear. Number one, state Kirchhoff's second law. Then you have to write just this statement with this equation, that's the mathematical expression. And if they say about the explanation, then you have to write this statement. You have to draw this circuit and write up to this part. Okay. So this is also a 3-star important topic for 1 marks and for 2 marks. So that's the end of our lecture. In the next lecture, we'll discuss about the single loop circuit and we'll use the Kirchhoff's law there. Please remain inside of your home. Stay inside, stay safe. Allah Hafiz, see you tomorrow.